Welcome back. In the previous module, we learned about basic components of a Hadoop cluster, HDFS, the MapReduce and YARN framework. So in this lesson, which is broken up into 3 videos, you're going to learn about major concepts and components for execution of applications on Hadoop clusters. So we'll look into some of the technical issues that might come up, some of the things that you need to tune, maybe on the system side, and primarily this is about the execution environments. So we'll focus on the MapReduce YARN environment to start with, but then we'll see how some of the newer environments work. So in the first video, we'll look at basically the basic execution environments in Hadoop, limitations of what is called the classic MapReduce framework, and then how the newer frameworks like YARN and Thais and Spark are trying to complement this classical MapReduce but with much higher performance. So as we discussed in the HDFS module, files are broken up into blocks, and these are stored on different disks spread out over a lot of nodes. So you can see this in this picture. Now the advantage of this is we are pooling the data resources across hundreds or even thousands of nodes, and this gives us lots of throughput. Basically, we are adding the performance from the disks on all the nodes. And you can see each node will have blocks corresponding to different files. So in this case, one of the files is split over n nodes, and it's shown in green in the blocks. The other blocks in yellow could correspond to other files, or they could be replica blocks for the file that we have. Now, to get good performance while processing this data that's spread out, we have to make sure that the compute parts in the processing are performed on the nodes that are already having the data. So ideally, you would put task 1 on block 1 there, task 2 on block 2 on node 2, and so on till task n on node n. This will be very scalable because each task is working on a piece of data that's local on the node. So we're not moving data around. And like we were able to pull the disk performance, we can pull the compute performance of all the CPUs on the nodes, so you get a lot better performance. Now, in the original Hadoop architecture, all the applications were executed via what's called the MapReduce framework. So what the framework lets you do is essentially run these tasks close to the data without having to worry about how it's done. That's done by the framework. So the data chunks are stored, and the framework knows about where they're stored, and it gets the task close to the data. And it also does the managing of the execution, monitoring the tasks, and restarting some if there are failures and things like that. The key here was all the applications had to fit the MapReduce approach. So you had to have these distributed data chunks and then mapper tasks which are independent of each other running on these data chunks, and then you had the shuffle process that would feed data into the reduce process. This works well for a lot of data processing, but what if your application doesn't fit this particular paradigm, or you can do it in this paradigm but is not efficient, and we'll look at some of these examples later on in this module. So the solution is what we're going to discuss a little bit later. So the cases where this might happen is if you're doing interactive data exploration, you might be looking at the same set of data over and over again. Now in the traditional framework, this would mean you would be loading the data from disk every time you're trying to look at it, which is obviously not efficient. If it could be stored in memory, you would get a lot better performance. The other case where this might happen is if you need an iterative data processing algorithm. And this happens in some machine learning algorithms, for example. So this is where the next generation frameworks like YARN and Thais and Spark come into play. They support complex directed acyclic graph tasks. So by acyclic, we mean not looping, essentially, in the graph. And also, some of these tools like Thais and Spark especially will let you cache data in memory, and that makes you get much better performance. So we will look at this in the next video in more detail and with some examples, so that clarifies things.